All right, let's take a look at part A here. The directions said graph each polar equation, support your answer with either a t-table or algebraic analysis. I'm just going to say I think a t-table is most appropriate. So for part A, R is half of your theta value, and they want you to use theta values that are 0 and greater. So just kind of getting started. So let's plug theta in and get R out. So let's say theta is 0, R would be 0. That would just be the pole. Let's say theta is something like pi over 6. So what's pi over 6? Well, pi is about 3, a little bigger. So pi over 6 is about a half. And so you'd have a half of a half, basically. So you'd have about a fourth. So you go toward pi over 6, just about a fourth of a unit. Let's see, let's plug in, pi over 3. So pi, again, is about 3. And so you just have half of something that's a little bigger than 1. So you have something a little bigger than a half. So toward pi over 3, out just a little bigger than a half. Putting pi over 2 in, pi over 2 would be about 1.5. And then you're taking half of that. So you'd have about 3/4. And you could keep doing all that accuracy, but I think if you were to just kind of do the 4 corners, that might be enough. So let's try it. So if you put pi in, you'd get, so for theta, that would be about 3.14, and then half of that, so just about a little over 1.5. 3 pi over 2 would be about 4.5, but then you're doing half of that, so 2.25 or so. And then if we put 2 pi in, you'd be doing half of that, which would be 1 pi, so just over 1, 2, 3. There we go, and then let's see if I can fill it in and make it look cute. If I can't, then I could, of course, go back and add more accuracy. There we go. Okay. Scoring for this one, let's see, let's give you... for just having something that looks like a spiral. Oops. Let's give you 1 point. And then 1 point for having it go kind of around like this. So let's call that the correct direction. And then we have 4 points left. So let's give you 1 point per point of accuracy. Up to 4 points of accuracy. So let's see, points of accuracy. At least 4 of them. That would be, so 1 point per point of accuracy, essentially, for a total of 4, and that's your 6 points. There we go. Okay, for part B here, graphing 2 minus 4 sine theta. You could have done a little analysis, I suppose, where you play around with the range of sine. So sine at the lowest would have been -1. So you would have had 2 plus 4. So r equals 6 is one of your, either your highest or your lowest value. And then if sine at greatest could be 1, and so that would be -2. So you're going to have r values that go from -2 to 6. And the fact that r goes from negatives to positives is an indication that you'll have an inner loop. So, and then other than that, it really is just a matter of doing a t-table. So the values that would make sense for a sine function here would be the 4 corners of the unit circle. And then for sine, the over 6s would make the most sense. So I'd be looking to make sure that you had at least 8 points of accuracy. The 4 corners are really important, and then the second most important would be the over 6s. As long as you have something in each quadrant, then that would be fine. So getting started here, let's see, we're going to plug theta in and get r out. So let's see, if theta is 0, then we get 2 out. Turn into that point. If theta is pi over 6, let's see, sine of pi over 6 is 1/2, so we'd actually get 0 out. And then let's see, if pi over 2 for theta, we'd have -2. Okay, so facing pi over 2, go away from it 2. Now, once you have these 3 points of accuracy, I do hope that you stopped and filled them together. So your R value would go from 2, and then as your angle increases, your R value would shrink down to 0. And then it goes from 0 to -2 there. Okay. Let's see. Let's plug in 5 pi over 6. When you put 5 pi over 6 in, we get -1/2 here, so you end up with 4 out. 1, 2, 3, 4. There we go. Okay, so your R value was negative. It must have become 0 somewhere in between the negative and the positive. I feel like I just messed that up. Did I totally just mess that up? I totally did. Yeah, that's not how it goes. Okay, let's try this again. 5 pi over 6. What's sine of 5 pi over 6? Oh, it's +1/2. Okay, 2 minus 2, 0. There we go. That makes so much more sense. Okay, yeah, there we go. Okay. Now let's put pi in. Okay. Sine of pi, 0. 2 minus 0, 2. There we go. There we go. There's the symmetry I was looking for. Okay. Let's put 7 pi over 6 in. Oh, there we go. That's when you get a sine of -1/2. So we'd end up with 2 plus 2 or 4. Aha. 7 pi over 4. 1, 2, 3, 4. Okay. 3 pi over 2, put that in. Sine of 3 pi over 2 is -1, so you end up with 6 there. There we go. And then you can put 11 pi over 6 in. Sine of 11 pi over 6 is -1/2, and so you'd end up with 4. There we go. Okay, now it's just a matter of trying to fill it in. Something that looks smooth and continuous. There we go. Truth is these probably go quite a bit wider here at the bottom. We would do more accuracy, but okay, there we go. All right, my friends, so points for this, you get 1 point for having a limacon. You get an additional point for having this inner loop. Like so. You have 6 more points that you can get. So 4 of those points are from plugging in 0, pi over 2, pi, and then I guess 2 pi. And so 4 points for plugging in 0, pi over 2, pi, oh yeah, actually 3 pi over 2, and 3 pi over 2. And then the other points of accuracy, plugging in something in quadrant 1, like pi over 6 or something in quadrant 2, quadrant 3, and quadrant 4, having those points of accuracy, those are an extra ½ point each. Okay, so like getting these points of accuracy, like this one, for example. Okay, so that's 8 points.